everyone, I am Denise Mariel F. Padua, a member of Group 1 from PCAS-06-101P, PS Psychology, and I will be discussing the meaning of chemical reaction and their different types. And without further ado, let's get started! I know you might be wondering, what is chemical reaction? And here I am to inform you its meaning. A chemical reaction is a process in which reactants react chemically and convert into products by chemical transformation. The substances that participate in chemical reaction are called reactants. The substances that are formed are called products. The products have different properties from the reactants, also known as chemical reaction or chemical change. As the picture shows here, hydrogen and oxygen are the reactants, while the water is the product. The reactants are what goes into reaction or what is reacting. The products are what is formed. The reactants are usually shown on the left and the products are usually shown on the right. We can see in this equation that hydrogen 2H2 is reacting with oxygen O2 to form water or 2H2O. Therefore, the reactants are hydrogen and oxygen, and the product is water. A chemical reaction is a process by which the bonds within the reactants molecules are broken and a new bonds are created within the product molecules to create a new substances. Understanding that chemical reactions are significant since they enable the growth, development, reproduction, and adaptation of living things such as cells, animals, people, and insects. Photosynthesis, rust, baking, digestion, combustion, chemical batteries, fermentation, and washing with soap and water are mostly examples of frequently occurring chemical reactions. Not just in chemistry lab, but all over the place, there are chemical reactions going on. Understanding physical and chemical changes is crucial before starting any chemical reactions. And now, let's classify the different types of chemical reactions. By examining the reactants, we can classify the reactions, then predict the identity of the products. Based on my research, there are 8 different types of chemical reactions. Let me discuss with you the first type of chemical reactions, the synthesis or known as combination reaction. One of the most basic type reaction is synthesis reaction, wherein a number of simple compounds combine under specific physical conditions to produce a single product. A compound will always be the final outcome. For instance, consider the combination reaction of sodium chloride with reactants solid sodium and chloride gas. Therefore, we have 2 solid sodium atoms that react with chlorine gas to form sodium chloride. In other words, the product was common salt. Next, we have the decomposition reaction. Decomposition reactions occur when a single component breaks down into several products. The environment must undergo certain energy changes in order to dissolve the bonds of the chemical, such as those caused by heat, light, or electricity. Consider the instance of calcium carbonates breakdown into calcium oxide or quicklime, which is primary element in cement. Thus, the compound calcium carbonate, when heated, breaks down into calcium oxide and carbon dioxide. The third is the single displacement or replacement reaction. One cation or anion trading places with another to generate a new product defines a single displacement reaction. When one of the reactants is an element and the other one is a compound, it is simple to identify the difference. Through the reactivity series, the products of these reactions can be identified. Reactivity series indicates that the components at the top of this reactivity series are more reactive than the elements at the bottom. An example of a single displacement reaction is reaction between potassium and magnesium chloride. As potassium is more reactive than magnesium in this process, magnesium gets displaced from its salt. The most reactive element is potassium, which is located at the top of the reactivity series. Next, we have a double displacement reaction. A double displacement reaction occurs when positive and negative ions of two ionic compounds switch places to form two entirely new compounds in an aqueous solution. As an example, when potassium nitrate and aluminum chloride react, aluminum nitrate and potassium chloride are produced. Under the double displacement reaction, we have precipitation reaction. In precipitation reaction, the ions of the reactants compound interchange to form new compounds. Consider two soluble salts in aqueous solutions are combined and form an insoluble precipitate. Next, we have neutralization reaction. A neutralization reaction is basically the reaction between an acid and a base, giving salt and water as a products. For example, hydrochloric acid reacts with sodium hydroxide, the base, and forms sodium chloride as salt and water. For the seventh types of chemical reaction, we have combustion reaction. Energy is released during the oxidation reaction, usually in the form of heat. Smoke, water, and heat are all the results of a reaction between fuel and oxidant, or often air oxygen. For instance, when methane is burned, carbon dioxide and water are produced. Lastly, we have redox reaction. Redox reactions are those chemical processes in which oxidations and reductions occur simultaneously. While reduction involves the addition of hydrogen and oxidations involves the addition of oxygen or removal of oxygen. An example of a redox reaction is a reaction of copper oxide and hydrogen. In this reaction, copper oxide has experienced reduction by the removal of oxygen, whereas hydrogen has undergone oxidations by obtaining oxygen atoms.
Greetings, I am Adriana Joy Somandi and I will be reporting what is copper. Copper is a chemical element in group 11 of the periodic table that is unusually good conductor of electricity and heat. It is reddish. Copper occurs combined in many minerals. Copper is commercially produced mainly by smelting or leaching, usually followed by electrodeposition from sulfate solutions. The major portion of copper produced in the world is used by the electrical industries. Most of the remainder is combined with other metals to form alloys. Copper is one of the most ductile metals, not especially strong or hard. Strength and hardness are appreciably increased by cold working because of the formation of elongated crystals of the same face-centered cubic structure that is present in the softer annealed copper. Common gases such as oxygen, nitrogen, carbon dioxide, and sulfur dioxide are soluble in molten copper and greatly affect the mechanical and electrical properties of the solidified metal. Copper forms compounds in the oxidation states +1 and +2 in its normal chemistry. Although under special circumstances, some compounds of trivalent copper can be prepared. It has been shown that trivalent copper survives no more than a few seconds in aqueous solution. So let us now move on to the material that will be used and how will it be used. First, 100 ml graduated cylinder. Graduated cylinder are used for measuring the volumes of liquids from a few milliliters to many liters. It is important to choose the graduated cylinder according to the amount of liquid to be measured for more accurate measurements. Next, beaker. Beaker are containers which can be used for carrying out reactions, heating solutions, and for water baths. They are for containing and transferring liquids, not for measurements. Dropper. It is a device that is used to transfer small quantities of liquids. Steering rod. A steering rod is made of solid glass and used to steer liquids in flasks or beakers. Watch glass. Watch glass is used to allow crystals to dry after they have been filtered. They can be used as an evaporating surface or to cover a beaker that can be heated to very high temperatures. Small-sized funnel. Funnels are used for pouring liquids from one container to another. In addition, with the air of filter paper, they can be used as separation device to separate liquids from solids. It is fixed by a ring support on a stand. 250 ml Erlenmeyer flask. Erlenmeyer flasks are conical shaped flasks which are made of Pyrex, are safe for heating solutions, recrystallizations, and chemical storage. Because of its conical shape, they are best for using with equipments with stopcocks such as separatory funnels and burettes. They are also like beakers, for containing and transferring liquids and not for making measurements. Next, Bunsen burner. Bunsen burner is used for heating when no flammable materials is present. The burner can be regulated by changing the air and gas mixture. Evaporating dish. The evaporating dish are made of porcelain or ceramic material to heat and evaporate solution to dryness. Test tube. Test tube are used as containers for solids and liquids to perform quick tests for properties such as solubility, effect of heat, etc. They can also be used as centrifuge tubes when a separation of solids and liquids is necessary. Pair of scissors. It is an instrument used for cutting cloth, paper, and other thin materials consisting of two blades laid one on top of the other and fastened in the middle so as it allowed them to open and close by a thumb and finger inserted through rings on the end of their handles. Vial. A small container typically cylindrical and made of glass, used especially for holding liquid medicines. Litmus paper. The use of litmus paper, which is red at any pH less than 5 and blue at any pH greater than 8, allows an inspector to determine only whether a solution is acidic or basic. More precise pH determinations can be found by using pH test paper, which compares subtle color differences to a color chart to indicate pH level. Zinc dust. Zinc dust is a zinc material in the form of a powder. Zinc is an important element with an atomic number of 30 and is found in group 12 of the periodic table. It is an important sacrificing element that helps prevent corrosion by sacrificing itself. Zinc dust may also be known as zinc powder. And lastly, filter paper. Filter paper is a semi-permeable paper barrier placed perpendicular to a liquid or airflow. It is used to separate the fine solid particles from liquid or gases.
I'm John Andre P. Puliket, and today I'm gonna discuss to you how the experiment called reaction of copper is performed. So we have 5 steps about this experiment. So the first step is the precipitation of copper to hydroxide. But before we proceed to that, the first thing that we need to do is to form copper to nitrate. So to form copper to nitrate, we need to react our copper sample with nitric acid. So if you already form your copper to nitrate, then you will now measure 5 ml of 1.00 m copper to nitrate solution into your 50 ml beaker containing 25 ml of distilled water. And with constant stirring, you need to add about 1 ml of 6.00 m sodium hydroxide to your solution. After you pour your sodium hydroxide in your solution, if your solution turns into like a royal blue color, then that's the desired product of your copper to hydroxide precipitate. But if your solution turns into like a light or baby blue color, then you need to add more sodium hydroxide into your solution until you achieve the desired product. The second step is the formation of copper 2 oxide. So we need to convert the copper 2 hydroxide to copper 2 oxide by heating or boiling your solution from step 1 for about 2 minutes with constant stirring to prevent bumping. So we need to stir it constantly because if we fail to do so, it may result in loss of material. So after that, when all of your blue copper 2 hydroxide turn into black copper 2 oxide, it's time to decant and separate it. So the third step is we need to convert the copper 2 oxide to copper 2 sulfate. In order to do so, we need first to settle our precipitate until the supernate is clear. So after your supernate is already clear, you need to decant the supernate through a filter paper into an earthenware flask. Then after that, you need to wash your precipitate in the beaker by adding 10 ml of distilled water. Then you need to settle again your precipitate and decant the wash water through the filter paper into an earthenware flask containing the filtrate. Then after that, you need to just repeat the process until the precipitate is washed a total of 4 times. And you need also to take note that we need to avoid putting all the precipitate into the filter paper because we do not want to lose all the precipitate. So the next step is you need to wash the same filter paper by adding 1 ml of 3.00 m sulfuric acid dropwise, catching the filtrate into the beaker containing the copper 2 oxide precipitate. After that, you need to dissolve the solid by swirling the beaker or by stirring the mixture using a glass rod. After that, you need to wash the filter paper again, but this time with 5 ml distilled water, catching the wash water into the same beaker. And don't forget to record your observations. So the fourth step is the reduction of copper 2 ions to metallic copper. So we need to reduce the copper 2 sulfate to copper metals using zinc. So in this step, we need to wear a face mask when handling zinc dust to prevent inhalation of the particles. And we also need to be careful not to let zinc dust into our eyes. If this dust or powders come in contact with our eyes, we need to wash it with running water continuously for about 15 minutes. If problems still occur, we need to consult a physician. So in this step, into your solution, you need to gradually add about 0.05 zinc dust with constant stirring until your solution turns colorless. And also you need to remember that you need to stir until there's no further reaction observed before adding more zinc. So after you obtain a colorless solution, you need to wash your precipitate in the beaker twice, each time with 10 ml portions of distilled water. And after that, you need to decant and discard the wash water after each washing. And also, you need to take care not to lose any of the solid. So in your precipitate, you need to add 20 ml distilled water and slowly add 1 ml of 6.00 m hydrochloric acid and stir the contents until no more change is observed. After that, you need to settle your precipitate and you need to decant and discard the supernate into a waste acid jar. After that, you need to wash again your precipitate twice with 20 ml portions of distilled water, and you need to decant it again and discard the wash water. After you transfer all the entire solid to a previously weighed filter paper, you need to fold the filter paper containing the solid and press this between pieces of a dry filter paper to remove most of the water. Then after that, you need to place the partially dried filter paper containing the solid on a watch glass and you need to air dry it. Then after that, you need to weigh the solid and filter paper and you need to record all the weights that you obtain. Since I've already discussed on how to perform the experiment called reaction of copper, now we need to know the proper waste disposal of this experiment. So first, we need to dispose the litmus paper into the trash can for solid waste. Second, we need to dispose the combined filtrate and washings in the earthenware flask collected in step 3. by pouring into the inorganic waste container. Third, dispose used filter paper in step 3 and step 4 into the trash can for solid waste. And fourth, we need to dispose the excess zinc dust into the inorganic waste container. And lastly, we need to dispose combined supernate, filtrate, and washings referred in step 4 by pouring into the inorganic waste container. So the last step is the oxidation of copper. So you need to place a pinch of solid into an evaporating dish and heat the dish directly over a Bunsen flame. Also, don't forget to observe and record your result. So that's all.
Hi, my name is Tristan Josh Leona from Group 1, and my topic is all about the expected result of experiment given to our group. Number 1. Precipitation of copper to hydroxide. Hydroxide ion binds to the copper to ion even more strongly than does a water. As a result, hydroxide ion can displace water from the copper ion, yielding copper hydroxide, a blue precipitate, and will be insoluble substance that will make the solution be saturated. 2. Formation of copper. We expect that along the stirring and continuous heat, it will decompose into copper oxide and will change its color into a darker color. Conversion of copper oxide to copper sulfate. As we add more water to the copper oxide, we expect the change of color of the copper sulfate. It will become lighter color blue as it converts to the desired product. Reduction of copper ions to metallic copper. The metal will reduce the hydrated copper and will be oxidized to zinc. Because of that, we expect the reduction of mass as it forms into a metallic copper, and it also can be a smaller in size. Oxidation of copper. As we heat it up directly in a Bunsen flame, we expect the change into a different color than the copper usually has. As it reacts with oxygen, it will become black in color and raises its mass.
I am Kelly Shanar Moyco, and I will answer question number 1 to 6. Number 1. What type of process and or chemical change is observed in number 1, 2, 3, 4.1, 4.2, 4.3, and 5? The type of process and or chemical change is observed in number 1, 2, 3, 4.1, 4.2, 4.3, and 5 is single displacement or reaction, because is a chemical reaction in which one element is substituted for another element in a compound, generating a new element and a new compound as a product. Number 2. Why must zinc be added gradually to the solution in procedure 4.1? When a strip of zinc metal is placed into a blue solution of copper sulfate, a reaction immediately begins as the zinc strip begins to darken. If left in the solution for a longer period of time, the zinc will gradually decay due to oxidation to zinc ions. At the same time, the copper 2 ions from the solution are reduced to copper metal, which causes the blue copper 2 sulfate solution to become colorless. On the other hand, on adding zinc to copper sulfate solution, zinc displaces copper from copper sulfate and forms zinc sulfate solution. It will undergo a redox reaction called the displacement reaction of metal, because zinc is more reactive than copper according to the reactivity series. Number 3. What is the purpose of the test using ammonia solution? This test uses sodium hydroxide or aqueous ammonia to test and identify metal ions by the precipitation form. Sodium hydroxide or aqueous ammonia is added to the solution being tested, and the color of precipitation form allows for identification of the compound. Number 4. Why must HCl be added to the solid after the reaction with zinc dust is completed? Zinc granules are the solid crystal of zinc. Zinc reacts easily with the acid to produce hydrogen bubbles. It is a single replacement reaction in which hydrogen is displaced by zinc metal to form hydrogen gas and salt zinc chloride. To form bubbles of hydrogen, zinc reacts rapidly with the acid. Number 5. Why is it not advisable to dry the copper directly over the Bunsen flame? Chemicals should not be dried by direct heating with a Bunsen burner because of the inability to control the temperature and likelihood of decomposing in the chemicals. The copper metal turns black when it's heated in the burner. Number 6. Calculate the percent recovery in the experiment. Does your result refute the law of conservation of matter, and explain? 96.21% in any chemical change, one or more initial substances change into a different substance or substances. Both the initial and final substances are composed of atoms because all matter is composed of atoms. According to the law of conservation of matter, matter is neither created nor destroyed. So we must have the same number and kind of atoms after the chemical change as were present before the chemical change. All chemical reactions are chemical changes. The law states that matter cannot be created or destroyed. In a physical change, substances can change form, but the total mass remains the same. In a chemical change, the total mass of reactants always equal the total mass of the product. If the actual and theoretical yield are the same, the percent yield is 100%. Usually, the percent yield is the lower than 100% because the actual theoretical value is the reason for this include incomplete or completing reaction and loss of sample during recovery. And that's all. Thank you.